All right, let's jump right in. Google just dropped a paper on what could be one of the biggest breakthroughs of the year. It's called TurboQuant, and it's aimed squarely at a massive crisis that's brewing in AI right now. Simply put, we are running out of memory.
And look, this is a huge deal. TurboQuant isn't just some tiny little update. It goes right to the heart of how these large language models operate, making their core architecture way more memory efficient. This could literally change the economics of the entire AI industry.
So, if that name, TurboQuant, sounds a little familiar, maybe like something out of the show Silicon Valley, well, you're spot on. In the show, Pied Piper was this game-changing video compression. This is basically the real-life version, but instead of video files, it compresses the working memory an AI uses to think, which is arguably way more important. So, to really get why this is such a game changer, we first have to understand the size of the problem it's solving. Let's take a look at AI's giant memory problem. The specific thing we're talking about is called the KV cache. The easiest way to think about it is like RAM for an AI's brain. It's the short-term memory. It's what lets a chatbot remember what you just said, or helps a coding AI keep track of the whole project. Without it, every single prompt would be a fresh start. It is absolutely essential. And this chart right here, this shows you the crisis perfectly. The supply of this special high-speed memory, HBM, that these models need, well, it's pretty limited. But the demand for it from all these new AIs, as you can see, it's just exploding. That growing gap, that's the whole problem. And really, it's a perfect storm. You've got AI agents coming out that use 1,000 times more memory. The hardware itself, HBM, is incredibly tough and expensive to make, so prices are just soaring. And it's not like you can just build more factories tomorrow. That takes 5 years. So yeah, we're in a real bind. But right in the middle of this pressure cooker, here comes Google with a potential way out. Let's talk about TurboQuant. It's powerful, and this is the most important word, it's lossless. So what does it do? First big number, 6x. A 6 times reduction in how much memory that critical KV cache needs. Just think about what that means. The hardware you already have can suddenly handle 6 times the conversation. And it gets even better. It's not just about saving space. It can also speed things up on the chip by up to 8 times. So you're getting more memory and faster processing. That's just a massive win-win. But, okay, this right here, this is the most incredible part of this whole thing. It does all of this without losing a single bit of data. Nothing. It is perfectly, completely lossless. Usually with compression, you have to make a choice. Save space, but lose some quality. Not here. This is the Holy Grail. So the big question is, how on earth did they pull this off? How do you get perfect compression with 0 extra baggage? Let's look under the hood. And don't worry, we'll keep it simple with some analogies. Okay, so the old way of doing this was something called vector quantization. Imagine you're packing a suitcase. You fold everything perfectly to make it all fit, but then you have to pack a whole separate bag just to hold the instructions on how you folded everything. It's inefficient, right? That extra bag is overhead. TurboQuant, it's like being a packing genius. You pack the suitcase so perfectly, so intuitively, that you don't need any instructions at all. That extra bag is just gone. It all comes down to this really clever 2-step dance. First, a technique called PolarQuant basically rotates the data. Then a second process called QJL comes in and acts as a perfect error corrector. All right, step 1, PolarQuant. Here's a great way to think about it. Imagine you're giving directions. You could say, okay, go 3 blocks east and then turn and go 4 blocks north. Or you could just say, go 5 blocks that way, while pointing at a 37-degree angle. See? Both get you to the exact same spot, but the second way is just way shorter, more efficient. That's what PolarQuant is doing to the AI's data. So what makes it perfectly lossless? That's step 2. What if, in our analogy, the angle wasn't exactly 37 degrees? What if it was like 36.8? That tiny little rounding error could send you to the wrong place. Well, QJL is this brilliant little math trick that acts like an error checker. It spots that tiny difference and fixes it perfectly, using almost no extra space, just a single bit of data. That 1-2 punch is the secret sauce that makes the whole thing flawless. And hey, this isn't just some theory on a whiteboard. They've tested this thing. It passed with flying colors on tasks like code generation and summarization. It even aced the famous needle in a haystack test, finding one specific phrase inside 100,000 pieces of compressed data. And maybe the best part? It's data oblivious, which is just a fancy way of saying it should work on any large language model, not just Google's. Okay, so the tech is clearly incredible, but let's zoom out of it. What does this actually mean for the industry? Who wins and who loses when a technology like this drops? Well, you can see the ripple effects pretty clearly. Google is a huge winner, twice over. They solve their own memory issue for Gemini, and they get a massive cost advantage. For a company like NVIDIA, it's complicated. I mean, if you can suddenly get 6 times more out of the chips you already own, do you need to buy new ones as quickly? Maybe not. Middleware companies get a bit squeezed, but the other huge winner? Enterprises. Any company using AI can now get so much more performance out of the hardware they've already paid for. Now, it's really important to put this in perspective. As amazing as TurboQuant is, you have to understand it's just one weapon being used in a much, much larger fight, the war on memory. Researchers are attacking this problem from all sides. TurboQuant fits into this one slice, quantization, but other brilliant people are working on totally different angles, like eviction, which is a smart way to throw away unimportant information, or even redesigning the AI's core architecture from scratch. The point is, the entire industry is laser-focused on solving this. And that brings us to what I think is the most important takeaway here. Building a new chip factory takes 5 years, half a decade. But an algorithmic breakthrough like this one, it moves at the speed of software. This is our fastest path to breaking through AI's biggest barriers. Software is eating the hardware problem. And this is why it all matters so much. You know, today, we get excited when an AI remembers something we said a few minutes ago. But technologies like TurboQuant are the stepping stones to a future where AI has persistent, long-term memory, a world where it's just ambiently aware. It sounds like science fiction, but that's where we're headed. Which leaves us all with one final, kind of mind-bending question to chew on. For the last century, we've built computers that just execute commands. So what happens to our world when we finally build an intelligence that never has to forget?